Hey, everybody, welcome back to the Doctor is In podcast. I'm your host, Nadia Saba. This episode is part of our special series on energy in CEA. Today, we are going to get into energy modeling with today's guest. Jeff Kelley is the founder of Kelley Energy Management, or KEM, which specializes in obtaining utility incentives and rebates for indoor cannabis cultivation facilities all over the country. In order to maximize the rebates for his cannabis clients, Jeff and his team have developed an energy model or energy models to demonstrate energy savings over time by implementing certain technologies and strategies within these grow facilities. His experience and knowledge has garnered the interest of the California Energy Commission, of the American Society for Heating, Refrigeration, and Air Conditioning, or ASHRAE, as we always talk about, who really want to better understand how much energy CEA uses, as well as what some energy efficiency strategies could be to reduce overall energy use, maybe more holistically than component by component that we see a lot with, say, lighting and fans and pumps. To do that, what we really need is an energy performance model to compare the proposed facility design and all of its systems to some standard or baseline design that would be representative of maybe a typical or a higher energy use CEA facility. This is not an easy task, and I'm really excited to talk to Jeff about his approach to developing an energy model that really, I think the idea is that the entire industry could use to help save you, the grower, some money in real time and really get not just incentives to apply your approach and your technology, but also to maybe find an alternative performance path for energy codes, whether you're in California or in other states that will eventually adopt them, but ultimately also to save you energy. So that is what we're going to talk about, is the power of using energy modeling for CEA. So Jeff, thank you so much
Hey,
for
thanks for having me.
being on the podcast to talk about energy modeling. I'm really excited to take a deep dive into this one very specific topic.
Very good. Yeah, it's been my world for 6 years now. So we're into many hundreds of models on different facilities. And there isn't a week that doesn't go by that we don't learn something new, but we've come a long way and we're getting closer and closer to nailing it, as they say. So it's good.
So I want to start with a fundamental question, just so everybody understands what it is we're talking about. So can you just briefly define for us what is an energy model?
So an energy model is a mathematical construct that's going to take situation or an example and run energy usage over a sort of prescribed amount of time. So if you took, like, say, your house, your TV runs 4 hours a day, you've got devices that are charging, you're cooking, cleaning, washing. You could put all those devices into an energy model, and if you did the energy model correctly, it would match your bills, and then you would know what you could do to reduce your bills. So if you saw that you ran your kitchen lights 12 hours a day, you could maybe lower the number of hours that you operated them, or put in more efficient lights, or anything like that. So it all boils back to things that we understand intuitively as far as our lives. But in the case of cannabis growing, it is just on steroids. There's a lot of energy that is used in indoor agriculture in general, and especially in cannabis. So we're just taking that basic energy model mindset that you could do for a home or a business or a school or a hospital, and going all the way up into the CEA world and doing it. The crowning achievement of an energy model is when it matches the utility bills.
Mm.
So, how do you know if you did an energy model correctly? Well, if you go back and you look at the model and then you look at the bills, of the customer and they're relatively close, you know that you've done a good job on your energy models. So that's sort of our goal is anytime we get a chance, we'll go back and look at the ex post energy consumption of a building. We had engineers calls from utilities saying, "Did you already know what their bills were when you did this energy model?" And we said, "No." They go, "You're within 2% of the actual kilowatt hours and the demand in your energy
Wow.
model is this customer's actual bills." So that was
Wow.
super flattering. You know, it's like,
Under
oh,
what circumstance are they approaching you with that question?
so utilities that are doing rebate work are very skeptical, or they do not want to overpay a
Mm,
rebate, for example, and then claim the savings back to their regulators. That is not realistic. So the reason that they're so picky is they want to say, well, if you said that this customer's design saved 1 million kilowatt hours, for example, well, we want to audit your energy model and make sure that we agree with it, that it's at least 1 million. And there are companies out there that are called EM&V evaluators. They go in and they look at that energy model and they say, that's wrong. I say that they only saved 900,000. And so the utility who paid out based on 1 million gets knocked for the 100,000 that they paid out that was too much. What we find is that the utilities are conservative and they tend to pay out too little. And when the energy model proves that they really saved a lot more than you thought, that's compelling also. So we had utilities that went back and awarded customers bonus rebates because they were too conservative.
really? Is that one of the advantages of using a performance-based approach for getting incentives? I mean, like I mentioned at the top in my intro, it seemed, like maybe the path of least resistance is to get rebates based off of a component, right? Based off of a lighting retrofit or replacing a fan or using maybe a staged fan instead of a single speed fan, something simple like that. Each of those usually has, right, like a set value based off of the power and the energy saved compared to some less efficient component.
Yeah,
Do you think that growers have the opportunity to actually get a higher rebate if they were able to take a more performance approach?
typically we've seen that. I've seen the utility err on the being too generous side, on one or two cases, but on the other 50, they were much too conservative. Because when you're talking about utility rebates, you're talking about companies that administer the rebate that aren't the utility itself. So there are contractors that are graded basically on how accurate their savings calculations are. You know, you could replace gym lights with LEDs and say that those gym lights ran 24 hours a day, which they didn't. And then
Right.
you turn in and you say there's all this savings. And then somebody says they don't run them that many hours. They run them 2 or 3 hours a day, Monday through Friday. And so then they wind up getting a bad score on that. So the whole energy efficiency industry kind of starts out with this thing called the Technical Resource Manual, or TRM. And that is where those individual rebates get set. It started with basically your Home Depot light bulb level rebates. And now they've gotten to where they're thousands of pages long. There was a rebate for putting better oil in a hydraulic pump or something. You know, they try to come up with a rebate for everything to make it easy. But the easy way is probably inaccurate and probably too conservative. So that was when I got into this industry, because I'd worked in the industry before as a rebate employee in a rebate company. The one size fits all rebate is just going to be super conservative. And so let's go in and let's do a holistic energy model. That was always built into the program. Very few people did it. Nothing against the mechanical engineers in the world, but they pretty much care about load. They don't care about energy. And you
Right.
very rarely find one that is trying to get it right on the energy side. They're basically is the when I sell this equipment, they put it in, is it going to work? I win, you know.
So when you say load, you really mean meeting peak loads in
Correct.
in the building and not really thinking about part loads or the dynamic loads within the building and how that might affect energy use.
That's correct. Yeah. What I found is that the engineers will add up the BTUs of the lights and come up with a sensible cooling load from that and do something with the evapotranspiration and all the latent load. And then they'll size their equipment. But a lot of them, especially in the early days, never asked the cultivation guy, how are you going to really run this room? Are you going
Mm,
to get into week 8 and 9 of the growth cycle and then try to make it super cold and super dry? Because your load goes when you do that. And that's been a big issue that we've seen in a lot of the energy designs is they have a cliff. So their customer gets to week 8 and 9 and they want to do all these things to dry the room and super cool it. And the equipment just quits working. It's not designed to do that. It's designed for the average. So that's an interesting part of the
yeah,
calculation.
I mean, you've been doing these energy models for utility incentives and rebates, you said for about 6 years now for the cannabis industry.
Yeah,
How did you approach it in the beginning? I mean, how did you figure out that these were dynamic loads? What questions did you ask? And were maybe some of your earlier projects maybe more conservative in terms of predicting energy use?
I think we were getting close in the early days to energy use, but I think there was some averaging in the loads and the way that we did it that was just based on some templates that we tried to use at first. So our
Okay.
first energy models were really based on a template that was made by Train, and so the
Uh-huh.
Train template that showed the negative and the evaporative cooling and the latent and the lighting, and it was getting close, but it was done like sort of without an instruction manual. It's just like we know these are the things that are there, put them in there, and then see what you get.
Mm,
And then as we got further into it, we were like, well, these rooms don't run 12 hours a day every day of the year. Say for a flower room, they run 12 hours a day every day for a cycle, and then they go in and they harvest the flower, and then they are not running, and then they come back in and they fill them up with plants out of the veg. So the cycle is just changing. So we've gotten to where we do that now. Like we'll put every room on its own schedule, and
okay.
scheduling is probably the biggest improvement that we've made is trying to mimic the way the cultivators actually run the rooms.
Can you give a specific example?
Well, so a good example might be we get the we get the equipment submittal from the mechanical contractor that shows the equipment that's going in. Then we'll go to the cultivation manager and say, how are you going to actually run your rooms? You've got 10 flower rooms, and they'll say, well, I'm going to run them on this week one cycle of 50% lighting, or it's based on PPFD usually, but the fixture that we're going to buy, we're going to run it at 50% brightness for two weeks until the plants get a little bit bigger and they kind of take root. And then we're going to pour it on. We're going to run as high of a PPFD as we can with the fixture that we've got that isn't going to damage the plant. So then they might ramp up their light to 80% brightness. Some of them, they'll ramp them up to 100% brightness. It depends on their secret formula. And then they're going to get into the late growth stages where they're trying to do what I call like a mimicked fall. And then they're
Mm-hmm.
going to try to make it drier and cooler. And then depending on the cultivar, what are they trying to do with that particular strain to make it the best saleable flower that they can get? So it's a lot of it's really listening and saying, we know that you're doing this, and we don't want to have your proprietary secret, which might be involved in some kind of secret sauce. But in general, this is what everybody does. How do you do it? That way, when we get the energy model back and we're comparing it to the more crude, inexpensive, less efficient way, we know that we're getting close to the savings that they're actually investing all this money and time in designing. and getting them the fair rebate that they deserve. So that's the main thing there.
So you just described a lighting schedule, right? And for flower production specifically. I mean, I guess I have a few questions here. One is when you are presenting an energy model to the utility, are you only presenting the predicted energy use and savings for the production rooms, or are you presenting that for the entire building operations?
In the beginning, we would try to get every room. We would do the
Hmm.
janitor's closet, the offices in the front, the different rooms in a grow facility. But then when we get the energy models out and we look at where the energy was going, it was 98% of it was in the flower and veg rooms.
Yeah.
So we've kind of gotten away from being too worried about this decimal dust of the
Mm.
hallways and all that. But you'd be surprised the utilities could, they'll say you could get more savings if you would put the lighting in the hallways in there, and because that's what they're used to doing every day.
Hmm.
So
Hmm.
it's more like where is the bang for the buck?
Yeah.
Dry rooms are an interesting.
Those are a good one.
Yeah, we found that dry rooms they kind of dry the plant out fairly quickly, and then just kind of sit there and
Peter along.
yeah, there's not a lot of energy there.
Yeah.
So
Interesting. There's a lot of energy at the first day or two, and
yeah,
then it just kind of flatlines to the
Yeah,
end,
it's like
right?
taking
Yeah.
your Christmas lights down and they're all covered with water. They're going to get pretty well dry by the next day, and then you could probably put them in a plastic bag, and they might have some drops on them, but they're not going to be like soaking wet anymore. So it's
Right.
just it's just interesting how as you go through it, it just changes, but it's kind of the same on especially indoor cultivation. Now I know greenhouses is your passion, and they are very hard to energy model.
Talk about dynamic. Yes.
Yeah.
You're
It's
not
like
just
where's
dealing
the
with
sun
the
coming?
things on the inside, you're dealing with everything on the outside. Yeah.
Yeah, yeah. So I've done a handful. I am not going to claim to be a greenhouse energy modeler. I can do an attempted energy. Hybrid greenhouses are a little easier because they have similarities to indoor growing. But just the regular old greenhouse, I'm almost switching over to Excel at that point, trying to
Yeah.
to do it.
Right.
So, and then
What tool are you using right now for your energy model? Is it something you guys have developed, or are you using a version of Energy Plus?
well, so what the program that we use is called Train Trace 3D Plus.
Yep.
You think of that as a program because a lot of engineers have used Trains Trace 700 over the years,
Oh
which
yeah, we have for sure. Yep.
yeah, it's written in DOS and it's coded. Train Trace 3D Plus is just really it's a front end for Energy Plus.
Hmm.
So it's basically menu driven Energy Plus. So the all the calculations go through the Energy Plus engine, and it's a very impressive program. And that is how do you do that? That's Energy Plus is changing, and you've got a front end that always is changing, and they have hundreds of people working on doing updates to Energy Plus all the time. So, in a way, we're doing Energy Plus, but in a way, we're doing Energy Plus using Train Trace 3D Plus. The 3D part of it's nice because you can go to a floor plan and draw a building, and most of the basic information is in there for the building shell without having to hand code that in or something.
Right, right. Do you
So
manipulate the results after you get them from 3D Plus, or are you confident in the results that they're putting out with the inputs that you're putting in?
we're confident as long as it corresponds to the real world. So if we run an energy model and it says the flower room is 400 degrees F. Well,
Oh
we
yeah.
made we made a mistake there somehow. And that program it has an interesting package called Visualizer, and you can kind of go into any part of the system and go in down to the 10-minute intervals and see exactly what's going on and why your energy model is seeming to put out garbage. So it's garbage in, garbage out. Anybody that does any modeling knows that. So the real world is your arbiter on that. Like if it seems like it's pretty well makes sense for that region, and one nice thing about Energy Plus is it links to the NOAA data for the nearest airport. So
Mm-hmm.
we did a real thorough energy model on in the Sacramento airport. I think your company is in
And
Sacramento.
we are, yeah.
Yeah. So when we went through and we did that, you know that the air hitting the condensing units is the temperature that it would be in
Right.
Sacramento. So if you put that same thing in Duluth, Minnesota, or in Atlanta, Georgia, your energy consumption is going to be a lot different that way. So
Can you
having it be
talk a little bit?
geolocated.
Yeah, I want you to talk a little bit about that because I feel like lighting is fairly simple, right, to model. Once you know what those schedules are, what the intensities are that they're going to, or that they intend at least to operate at different weeks. I mean, it's watts. I mean, that's fairly,
Watts times
it's,
hours.
yeah, it's fairly straightforward. With HVAC, however, not so straightforward, and you just brought up one of the reasons why it can be challenging to model HVAC, right? Which is that the efficiency of the HVAC system is closely related to what the outdoor conditions are and its ability to reject the heat from inside to outside. So, like you were saying, in Sacramento, if it's 105 degrees and we're trying to keep it, 70 degrees, say, inside, it's actually hotter outside than it is inside. And so it's hard to reject heat to somewhere that's hot. But if you're in Duluth, Minnesota, and it's 50 degrees and you're trying to reject that heat, no problem. In fact, maybe you even just ventilate at that point. Can you just explain? I mean, that's just one efficiency challenge when it comes to an HVAC system. But how do you also, you had mentioned, mechanical engineers, we like to design things based off of load, based off of peak load to make sure that we don't come up short. But what about those part loads? Like how have you guys learned over the last 6 or so years to track energy use with the HVAC system based off of what's happening with the lights inside and the set points as well as what's happening outside?
The biggest thing with HVAC is making sure that you're using a curve that makes sense. So, like my house, I have a 3-ton air conditioner. Well, it's my house has a 3-ton air conditioner at design conditions, which is one point on a curve. That is,
Mm,
it's just something that so people can talk about it. It is not something that you do calculations with. And so in the Energy Plus modeling, it's gonna look at the sensible heat ratio and the way that the outdoor air is hitting the condenser, and it's doing this complicated math every hour of the year to go come up with the energy consumption. So if you do that correctly, you'll get the right answer. If you do it incorrectly, you will get a crazy answer that
it'll be
doesn't
all
make any
over the
sense.
place.
Yeah. But the biggest problem we've had with the HVAC industry is a lot of the purpose-built cannabis equipment has never really been tested in the AHRI conditions, and
Mm,
those conditions don't even make sense
right,
because
right,
this is a machine that's going to run when it's 5 degrees outside. So
right.
what number is that at 5 degrees? AHRI is all based on getting it down to what 50, high 50s or 60 degrees. It's comfort cooling. So
Right.
it's just
Yeah, and
it's
how
sort of
often
like
does a grower operate at 80, 60?
yeah,
Yeah.
yeah. And then the same thing with dehumidifiers. The side of the dehumidifier says 506. So everybody's like doing math on that.
Yes.
506 times 3. So I've got this. It's like, no,
Divided
you
by
have,
24,
yeah,
24
yeah.
hours, right?
And
Yeah.
so they're doing all this math, but it's like that's just a point on a curve. So you got to
Right.
solve it across the curve. So that's where we've had a lot of luck with the dehumidification market. People like Dan, that he'll give us the curve because they have that
Right.
unit in a lab and they run it. But be like, Dan, how come it only goes down to this number? He goes, well, our lab's not big enough and we can't do. So you're still getting projections at some level. Then you got to go back to the real bills and go, does this work? It's like, well, it must be relatively close on the energy model. So,
And I mean that you bring up a really good point, which is that because the testing standards for standalone dehumidifiers or really any dehumidification equipment is based off of, I guess a residential comfort cooling or comfort dehumidification standard, it doesn't really represent all the points on the curve that we know growers want to operate at. And so we know, companies like Quest and Andon and others have tested, right, the dehumidification capacity and energy use at different points that are more realistic for growers. But unfortunately, they're not required to report them. They, are doing it under their own sort of, testing chambers. It's not, done under stringent standards. I think they're all trying to do the best they can. I think that all the intention is right. But because they're sort of strapped by what the federal regulations are, that's a real problem when it comes not just to growers trying to get the right dehumidification capacity, but for folks like us who are trying to actually predict how much energy use they're going to use under these different conditions. And if we don't have that data, then we can't get to 2% accuracy or probably even 20% accuracy.
yeah, it's an interesting blind spot
Right.
of
Yeah. Yeah. That's a good point. Yeah.
CEA. It's like, well, there is no target. There is no, we've even seen utilities, they'll say at the beginning, it was 1.9 liters per kilowatt hour is our dehumidification baseline. And they would just say that. It's like, you got to say 1.9 liters per kilowatt hour at 80, 60,
When?
and what
Yeah,
80 and
exactly. Under
60
what
mean.
condition?
And then you got to have a curve on it. And it's like, but in their defense, they're trying to give a rebate out for anything that saves energy in
Mm,
the world. And they're not strictly doing CEA. And so they wind up taking a shortcut and giving a rule of thumb and doing things like that. But the manufacturers are usually very willing to give us the data that we need, but it's expensive to get a lab built and to take your 40-ton hot gas reheat variable speed compressor in there and run it through all its paces for a year. Like that would be too costly. Well, it's many more than 6 years into this industry, but it's still kind of early days in terms of the knowledge level. It would be nice if academia built a lab and said, we're going to really test this and have empirical data that comes with your unit so you can plug it into the curve when you do your energy model and it will give you the right answer. Another thing that's interesting to me is dehumidifier is used for something that is made to do that, but it's in a room full of these other huge dehumidifiers, which are air conditioners.
right. I know.
So your air conditioner is a dehumidifier, your dehumidifier is a dehumidifier. Even engineers that I talk to, they don't seem to understand that. So when the
Hmm.
40 tons of other dehumidifiers turn off, the other dehumidifiers come on that are in the room that are taking out the humidity because the sensible load from the lights goes away. And it's just so foreign to most people that are designing schools or office buildings or comfort cooling systems. So
Right, right. I like working with engineers who are in the South. because they understand humidity. They understand the psychrometric chart. I don't have to explain it to them. They understand that the air conditioning system is a dehumidifier. And so I always feel like I get to start at a more advanced level of a conversation when I talk to other engineers from the southern states that are humid. Yeah, out here in California, I mean, it would be very rare to meet an engineer that understands the psychrometric chart. I've had mechanical engineers admit to me all the time that they don't know how to use it. I'm like, oh my God, like that's the tool we use the most, probably.
Yeah, that is the holy grail, is to understand that
Yeah,
and then design your equipment so everything nudges that little dot around inside of that box that you need it to stay inside of. So
right.
yeah, that's a huge thing. And that's what I really need to give a shout out to Brett Kelley. Brett is my son, and he has gotten so good at energy modeling that he's really in demand now with a lot of the code writers, and like, so you really understand this stuff. So he's done a really good job.
That's awesome.
Yeah.
Um, so I want to stick with HVAC for just a second because there's
Okay.
so many different HVAC systems out there. Let's just forget about standalone dehumidifiers for a second. And if we just talk about the air conditioners, whatever type it is, well, maybe not whatever type it is. Let's pick on integrated package DX with hot gas reheat kind of systems. There are a lot of different models out there, right? Some that have multiple single or two-stage compressors, some that have digital scroll compressors, some that have a digital scroll plus a two-stage compressor, right? Some that are all on the same refrigerant circuit, some that are on 8 refrigerant circuits. How do you guys model the compressor energy use under different loads and with different types of compressors feeding off of each other? That does not sound easy.
It kind of boils down to how the curve is going to follow the load. So if
Okay.
the compressor can slow down, but most of these units have two or three compressors. And then the hot gas reheat circuit, the way that it's plumbed. Let's just put it this way: in our program, there is no fill in the blank way to do that. You have to kind of like get at it and then see if it comes out in a way that makes sense. So I would say that we don't have the sticks to build that system exactly correctly. You can identify a lot of the pieces, and the program will pick up on the way that it's supposed to operate. But it's a little bit of a challenge when you get into, basically, if you take integrated systems, they're basically built to be constant volume air conditioners that run during the day, and then they're like transformers. Then at night they become these really slow, high dehumidification level units that run at night with hot gas reheat providing the heat. So
Hmm.
they basically transform themselves into a giant dehumidifier at night. One of the design things that we've seen with those manufacturers is adding additional hot gas reheat circuits. I think the original hot gas reheat unit was kind of designed for an exercise place or something where you had all these sweaty people and you didn't need that much reheat. But if anything, what we find in the newer units is they've got more and more hot gas reheat circuits in there. And you really,
Right.
really need that. Reheat,
125% reheat, right?
yeah, reheat
Captured.
is the whole thing. And I remember doing a design one time on a chilled water with a natural gas boiler reheat system. And I was like, I can't get any savings out of this system. And it's like, well, it's because you need so much reheat. If you're going to have discharge air temperatures of, a few degrees below the set point of real dry air, you need to heat it up a lot. That was something that came up in the Title 24 conversation was, if you're going to put in a chiller, you need to put in a heat recovery chiller that is going to be essentially a hot gas reheat DX type
Mm,
system. Thankfully, we've seen most of the newer ones that have gone that route.
right.
Reheat is just a huge issue in there. Can I take the very best thought of unit A and then compare it to unit B and all the little minute things that they've done to make it better, we're going to be crudely evaluating that because it's just not, the program isn't sensitive enough to do that.
Right. I mean, do you talk to the manufacturers about the sequence of operations, at least at a high level of their equipment? So if they had a digital scroll plus a two-stage compressor, do you talk to them about, which is the lead compressor, which is the lag compressor, and how they work together, and when you would expect one to switch over to the other?
We'll look at it that way, and then we'll look at the program and go, is the program going to pick up that particular
Mm,
thing? So then it kind of becomes like, what's the KW per ton online at the set point, that point in the cycle of the unit? So you're kind of doing an abstract thing to model that.
right,
So
right.
I've always been a little surprised that the people that build these units don't really embrace us and give us more and more data to try to get more incentive out there. Because I've always felt like on those
Mm,
units, there's more savings than we're probably calculating because we just don't have the tools and the performance curves to actually put that unit into the program and operate it for a year.
right. I mean, on that point, there are people who are convinced that an integrated package DX system with hot gas reheat is the lowest energy using system compared to, I don't want to talk about chillers quite yet, but compared to the decoupled system, right, of fan coil units or some split air conditioning system plus standalone dehumidifiers. In all of the energy modeling that you have done, would you agree with that statement that integrated package DX is always more efficient than a decoupled split with dehumidifiers?
In general, that does pencil out in the model.
Okay. Is
So
it big? Is it a big difference?
it's not jaw-droppingly big. It's better, but
Okay.
it's not unbelievably better. I don't know. I'd almost have to like
Okay.
give you some example energy models. To me, being somebody that's always worried about what things cost, is the cost premium worth it in the energy savings? That's where the rubber hits the road on that. Is like if it's $2,000 a ton more to do this, then the savings is there. But it's just like, would I buy a car that got 60 miles at a gallon if it costs $10,000 more? Like maybe not. Maybe if it costs $3,000 more, or I could calculate it out.
Right.
So
What's your payback? What's the return going to
yeah,
be?
what's the
Yeah.
ROI on that? But yeah, just in general, when you model it, the integrated systems are going to be in DX. If you're going to be in DX,
Right.
would be the lowest cost systems to operate. But we do have an interesting thing that we've come up with. Well, we didn't come up with anything, but that we started to evaluate, which is the idea of toggling the lighting. So when you've got, say, 10 grow rooms and they're all coming on at 7 in the morning, the utility bill is going to show 7 times all those lights and all those air conditioners running through the peak period of the day. So if you can take half those rooms and run them at noon and the other half come on at midnight, you've reduced your draw on the grid by 30 or 40%. That is an unbelievable amount of savings that you wind up getting on your bill. It's not an energy saving thing, more of a demand saving thing. But it's sort of like ice storage. I don't know if you go back to
Yeah. Thermal
the
energy
days of the
storage. Yeah.
popular ice storage where, well, your machine sits there all day and you don't have to run it. You just melt ice all day. So it's sort of the same thing with cannabis. And I think that's an exciting new thing with bringing in the control systems and designing the system to operate that way. And I think that's going to be something that people will have to look at going forward is basically trying to have a flat demand system that runs the same amount of KW all the time.
Right.
So
I
it'll go
mean,
up and down with the hot weather, but not
sure.
that much.
I mean, there were a lot of growers that we talked to in the early days who had considered that strategy of operating half the rooms on one schedule and then half the rooms on the other schedule, or maybe just running all their rooms at night because the cost of energy is lower during off-peak times. And so there are growers who maybe started with that strategy, but then it became really challenging to find people to staff that facility when the lights are on in the middle of the night because you really can't go home and expect, right, the all the pumps to not fail and all the lights to turn on when they're
Yeah,
supposed to, etc. And so, although we saw a lot of interest in that as a energy money savings strategy, we don't hear that often anymore from the operator grower side because I think they've all just, not all, but I think many of them have decided that it's just not worth the stress of trying to hire good people to want to work in the middle of the night. And so then they end up, the directors of cultivation are all staying up at night watching their phones, waiting for something to fail. So,
right, right. Yeah,
yeah, there needs to be more
the
fail safes.
practical matters always
Right.
take precedent.
They do.
But in terms of just being an energy guy, it's like if I can knock 300 kW a month off your bill by you just going into your energy management system and programming it differently and show you what that would save. I'm in Kansas City right now. I had a grower that opted for that and several other ones, and they were saving $180,000 a year in just
Wow.
electric cost. So does
Nice.
that negate having to bring somebody in and the pain in the neck that is? I
Right. If
understand.
you have to pay someone $180,000 a year to work in the middle of
Yeah,
the night,
yeah.
yeah. Right.
So I'm thinking maybe with better sensors and more AI, not AI, but like just better energy management controls, you could kind of like get all green lights on your room when the lights came on at midnight, and then wait to get in there at 6, something like
Right.
that.
Right.
But again, I'm not. I don't own one of these facilities, and they're probably laughing in their beer right now, going, "No, I'm not doing that," and that's fine. It's just like here's something you can do. You can either do it or not do it.
Right, right. Uh, Just kind of going back real quickly to the difference between those two HVAC system types. Is there a facility size? Because you said in your response, it seemed like you're kind of going through your catalog of projects maybe in your head, and that you were thinking, well, maybe there are certain projects where it was a slam dunk, and there are certain other projects where it was kind of a tight race to the energy finish line. And I'm just curious if that has to do with scale, if it has to do with the number of production rooms they have, or the type of system that they were proposing to use. You said DX to DX. Like, what if the split system was a heat pump? Like, would that maybe edge the race a little bit closer? I'm just kind of curious.
Yeah. So we've looked at heat pumps. They're rarely going to pump any heat. Like there's split systems. You can almost take the heat pump wiring out of it and just run it. It's just a heat pump.
As an air conditioner. Yeah,
It's just an air
exactly. Yeah,
conditioner.
yeah.
So there's certain things that are like the flavor of the month, like VRF systems.
Sure.
So VRF, if you've got an office or a school where it's sunny on one side and cold on the other, and the VRF system can move that heat around in the building, it's unbelievably great. But in a constant volume box, which is a flower room, I'm not sure what it's doing for you by being variable, other than maybe being
Right,
variable speed.
right.
So I'm sure that,
Which kind of
some,
goes to your point too. If you could swap rooms, right? If you could stagger half your rooms with lights on and half your rooms with lights off, maybe there is where your VRF or energy recovery heat pump system could actually do what it's intended to do.
I would love to see somebody do that on paper and see what it would do, because it would
Yeah,
definitely make your system smaller, wouldn't it? You'd only
sure.
have half the lights on at any given time.
Right.
It also, if you design from the ground up with half the lights on, is your switch gear and the transformers, everything can be sized smaller because the
Hmm.
plan is not to operate it all concurrently. And
Right, right.
utilities are well aware of that. When you go to the switch gear and the wires are this big around,
Yeah.
and then you go to the wire coming in from the pole and it's as big as a pencil, the utility knows you're not going to pull all those amps at one time.
Right.
They're going to supply you with some sort of an average load that's got some diversity on it. So
Hmm.
anyway, I love
So,
this stuff. It's great.
I mean, okay, one of the things I feel like we're tiptoeing around is what our standard or baseline building or systems are. Because if for the utility, we're trying to demonstrate that there is a savings, then we have to compare it to something else, right? So do what do you use as a standard or as a baseline? Does it change from building to building, from location to location? And do you think we have the right baseline, or do we need more input maybe from growers to help us determine what that should be?
So what we've always done on the baseline, if you go into like IECC or some other code, a lot of times it'll say this, what is the scope of this code? And it doesn't say cannabis production facilities. So everyone that's using a code is adding cannabis into it. So what we'll usually use is the local jurisdiction's baseline for ASHRAE 90.1. So if they're
Okay.
putting in a 40-ton unit, we'll go to the year that they use, and we'll do the baseline on the efficiency of that unit that's allowed in that jurisdiction.
Okay.
So it's basically going to the code book and kind of giving the utility an idea. Well, we're not saying we're going to put 400 three-quarter ton window units in just to drive up the energy consumption and make it look crazy. It's like this is what you would do in your jurisdiction. You would go to the code, and you would do your sizing, and then you would put in a piece of equipment that met the code at that size. So that's the baseline on the HVAC side. On the lighting, it's basically kind of morphed over the years. It used to be the 1,000-watt double-ended HPS fixture was the baseline. But what we've seen in the last 5 years is the PPF coming out of a fixture has gone up so much with some of these newer LED fixtures that the baseline is, in some jurisdictions, they'll want it to be an LED of a certain PE ratio, which is watts compared to PPF, or photosynthetic photon flux, for everyone that wants to have trouble falling asleep tonight. They can think about that. But so anyway, that's the amount of photons that make things grow. So that you do this in a lab and you measure it and you compare it to how many watts it takes to make those photons, and that's called the PE ratio. So that's gotten to be sort of the lighting baseline now. Is it 2? Is it 2.5? Is it 3? Is it 1.7? You know, that gives you a number you can compare to.
Does every
And
jurisdiction that you would have done work in have a minimum PPE?
it's
And
I think the utility has a book that they refer to. So it would be probably come out of their technical resource manual for that state.
okay.
So I think California has just recently changed its PE ratio, and you know it's a little squirrely of a number because, well, how far is the fixture from the canopy?
Right.
It's like, is a flashlight brighter when you shine it right against the wall or when you back up 10 feet? That is the way that you design lighting, is by at the surface where you want it, like a lighting
Mm,
designer would. So Anyway, I know I'm flying around all different kinds of subjects here, but the basic question is, what is the baseline? It's morphing now. It used to be HPS and code HVAC equipment, and now I think it's going to start to change, especially on the lighting side, to being more about the PE ratio of the LED fixture, or if they allowed HPS fixtures, the PE ratio of a grow light designed fixture there. So that's what we've been using.
For the HVAC system, I mean, the energy efficiency of a lot of air conditioners, I would say, exceed the EER of HVAC units that are being used for dehumidification, at least at peak loads where, right, we're sizing and specifying the equipment. When you spread that out over the entire course of a year, for example, I'm not sure if that statement holds true under every situation. But I guess I'm just curious if you're using an ASHRAE standard that would have a relatively decent energy efficiency ratio, and then you're comparing it to a piece of equipment that we want to dehumidify under non-standard conditions, and the EER is maybe 8.6 instead of 10.9 or something.
Right.
How are you even showing energy savings with the HVAC system?
Well, it's basically you turn on the energy model, and sometimes the 8.6 beats the 10.5.
What?
EER is just a point on a curve at design conditions for comfort cooling. But it doesn't mean that that machine does this better, this particular witch's brew of humidity and heat and things and these crazy levels in these grow rooms. So yeah,
So I don't understand what that means. So if ASHRAE is saying that this is going to be a rooftop unit of some capacity because you're in a certain climate zone or whatever, I guess I don't understand how that unit would be less efficient than a similar unit that has a dehumidification capacity. Does something happen with the capacity of the unit that you're saying that if we have, let's just call it a zero point 0.5 sensible heat ratio. I'll just keep it
okay.
simple, right? Where comfort cooling in an office would be like a 0.85 sensible heat ratio. Is there something in Energy Plus that says, oh, with a 0.85 sensible heat ratio with this rooftop DX unit means that I'm going to need, I don't know, 4 times the amount of equipment compared to an integrated package DX unit that has dehumidification capacity, that I only need one of those, but I need four of the other. And so that's why the energy use would be less with the purpose-built unit. Is that
Yeah,
why?
I think what it is when you feed it into the room and the load is moving every hour. A lot of the time, it's a rooftop unit that's really running to be a dehumidifier, in that the primary output of it is dehumidification. So you've got all this stuff going on in the room, and
You're
you're using
oversizing the sort of
yeah.
conventional piece of equipment to manage the latent load, where a purpose built is going to be a much smaller, I guess.
Well, it's going to kind of have a variable, sensible heat ratio. In other words,
Right.
as the machine starts to see the room change, it's going to sort of it's got controls that are going to make it turn into a giant dehumidifier. So we've actually seen some equipment manufacturers sell the unit as a dehumidifier and not even publish an EER, because
What?
people want to call it an air conditioner, and air conditioners have an EER. So I'm not going to call my unit an air conditioner. I'm going to call my unit a dehumidifier. And
Wow.
then I'm going to list its dehumidification efficiency. So it's like a dehumidifier that also cools instead of a
Interesting.
air conditioner that also dehumidifies.
I mean, that was the original purpose of air conditioning, right? Was dehumidification.
Oh yeah.
So it kind of, again, full circle.
No, I haven't invented or discovered anything new. It's like all this stuff preceded me by many years, and it's just an interesting way to go in and try to figure it out.
So, do you help your clients? I mean, if we're talking about the HVAC system, and I had asked you a question about like the decoupled system versus the packaged integrated DX unit. Honestly, I'm kind of glad to know that the decoupled unit system isn't considered the baseline. I like having the feeling that a decoupled system could still outperform a rooftop unit because now we do have dehumidifiers that are doing dehumidification on purpose, not as a result of air conditioning. So do you use that? Do you have clients that say we're interested in looking at two different systems? Like, will you use it as an alternatives analysis, or are you guys really more focused on utility rebates?
So in a handful of instances, we've been asked, compare this to that, you know,
Okay.
run this system and then run this other system. What we don't want to do as a company is put our thumb on the scale for anybody. So in
Mm,
other words, when you've decided what system you're going to buy, we'll model it, and then we'll see what kind of a rebate you could get for it. But we don't want to say you really should buy product A because product A beats product B, and that sort of thing.
right.
That's professional suicide for what I do because product B, who I said loses, will steer away from anything that I have to say from then on.
Mm,
So we just try to like be like, you're this much better than baseline. You're not this much better than
somebody else,
somebody
another
else's
system.
brand or
Yeah.
whatever.
Right.
It's just a business decision. You know,
Sure.
we could sit there and put five different systems into an energy model and have an energy model race that, you know, who wins and that sort of thing. But I think that's another reason why the manufacturers don't want to give you all the data is, and this is the entire HVAC industry. They don't want people to know the truth. They want you to pick a number off of a brochure and say, I want that one.
Right.
I want a 15 SEER. It's way better. It's two better than a 13 SEER. They don't want to tell you that that will save you $30 a year on your bill and it costs
Mm,
$2,000 more,
right.
you
Right.
know? So it's sort of like, it's all part of the sales game, I think, but
For
that's
sure. For sure.
just my opinion. Yeah.
So we've talked a lot about HVAC and lighting, but in a whole building performance energy model, there are other components, right, that also get built into that. Can you just talk briefly about that? I mean, I know, HVAC and lighting combined probably use 80 to 85% of the energy in a CEA facility. But where are other opportunities for growers to save energy that might be included in your model?
Occasionally, building shell can become an issue. What I've learned indirectly is that most flower rooms are big ice coolers that have air conditioners in them. In other words, the heat can't get out. I had a guy one time, he said, make that back wall R30 and tell me what it does. I said, well, your bill went up by $400 a year when you did that. The heat flow is out, it isn't in. So in the summer, there's hardly any heat getting. Most of these indoor grows are, they don't really have a lot of skin load. And when we do the load part of our calculation, we're not seeing much there. The other thing that we're seeing on building shell or room design is a lot of circulating fans.
Yep.
So getting the most efficient circulating fans is a good idea. Another thing would be making sure that you've got walls that are the same temperature as the air. You don't want your wall to be cold.
Cold.
A cold wall is a mold wall. So
Right.
don't put in a thin wall and expect it to stay the same temperature as the air. So that's a big deal. I've had guys that they were using drywall on the inside walls of flower rooms,
Oh,
and
yeah.
the drywall screw heads were the problem, and they got cold, so they were like building something
The
over that.
thermal bridge. Yeah.
Yeah, so there's just a lot of like little things. Definitely go with lighting control systems. You don't want to be monkeying around, turning things up and down, and you're going to need that. So that's another good design thing. And most of the growers, they use an entire energy management system. So they're solving for vapor pressure deficit all the time. Also understanding the relative humidity versus actual water in the air. That
Hmm.
there's certain things that are design considerations. And some of the things that I'm uncertain about that I've heard lately is like green lighting in rooms. Can you go into a room that has green lights and it's not, and you're not going to damage the plants? That would kind of make the toggling thing easy. Just, well, you're going to go in and use green lights. But I've heard people say use green lights at your own risk, that
Yeah,
you
I
might
would be in
wind
that
up
camp.
ruining $1 million worth of product.
Right.
So, but yeah, you're right. It's the biggest load is lighting, fans, and HVAC.
Right.
Another good best practice is having the fan in the room on the air handling unit and just having it dump back out into the room. So you don't have static pressure issues of pulling the air all the way through a long series of duct work to get to the room. That seems like that's an energy saving thing.
Are you
Um,
saying to just discharge the air directly from the HVAC unit to the room?
well, in other words, keeping the duct runs as short as possible.
Oh, sure. Okay.
So in other words, if you've got your return air in the room there, where it's going to go up into the fan and then go back out through like duct socks or something, that seems like a very efficient way to eliminate static pressure issues that can run up your bill.
On the shell, you made two almost contradictory statements. So I want to kind of hone in on that a little bit. So you
Uh-oh, I'm
said
in
too,
trouble.
no, you're fine. Too thick of insulation, and you created a nice box where he can't escape through the wall. But too thin of an envelope, and you might start to see condensation on the inside because the wall can get cold outside.
Yeah,
So where's the balance?
I think where I've seen the industry go is the room within a room approach. So
Okay.
you have an interstitial space, and you have your grow rooms are really 75 degrees on the outside. There's not a big delta T across the wall.
Okay.
And so that's I think how people are dealing with that. Some people will build them along an outside wall and then have plenty of insulation. Insulation is a diminishing return problem. So R60 is not better than R30. R30 is enough. And so you can get to where you're just throwing money away. Like you might as well just put dollar bills in your walls. So it's picking that temperature that you want to maintain. And it's really up to the engineer. It's like, what's my coldest temperature on the other side of that wall versus the temperature that I want to have on the inside of the wall, and then design the installation accordingly.
Right.
So
And I think also depending on if you're in a predominantly very cold or very hot climate, right? I mean, if
yeah,
you're in Billings, Montana or something where it's really super cold in the winter, then having more insulation to prevent cold walls, cold roof, and condensation makes more sense than if you're in temperate California where, the temperature probably ranges between 30 and 100 as opposed to negative 30 and 80.
right,
Yeah.
right. And so I think that's where your builder and your design engineers, they need to just do the best practice for the region that you're in.
Right.
It's not really a cannabis thing. The other thing is especially if you're running not toggling, where you've got a whole building full of just dehumidifiers running, for example. then you could wind up needing supplemental heating late in the photo period off period. And then
Right.
that's another issue is when do you design the building so that you have enough heat that you can kick on and keep the room at the set point for just like a regular furnace or whatever. But again, we're not designers. That's where you got to talk to your mechanical engineer and say, there is going to be this time at 4 a.m. in February where this room's going to start to get cold, and what are we going to do about that?
Right.
And then you get into the whole electric versus gas and things like that. But I would say normally in the designs that we do see supplemental heaters on the units for those times of day.
Yeah.
So
And we certainly have specified auxiliary reheat in addition to hot gas reheat for our projects that are in very cold climates because sometimes hot gas reheat can't quite get there because we might not need a lot of dehumidification, which means we don't have a lot of heat to recover. But if it is very cold outside, say -30, then we still might need to actually just heat the
right, yeah,
space.
yeah.
Yeah, but something that we have learned, unfortunately, is that a lot of the HVAC units lock out simultaneous heating and cooling. It's in ASHRAE, it's in a lot of building codes, and so it's either one or the other. So we've been working also with the folks at ASHRAE 90.1 to make an exception for indoor agriculture to allow that simultaneous auxiliary heating with air conditioning, at least under certain conditions or
Yeah,
in certain
if you had an
climates.
integrated unit and
Exactly.
you're losing the room. Yeah,
Right,
you
right.
just need to.
Have you ever been able to get incentives for a grower using ventilation or air side economizing to reduce their compressor usage?
In the early days, there was a unit that I did where it was basically, and it was unbelievable how much fan energy they used.
Oh, well, yeah.
But but you can do that, like sort of like a heat wheel that
Mm-hmm.
and that was what I remember doing the model, and I was like, look at this fan energy. It's blowing the heat out of the wheel, and it takes a lot of CFM to do that. So, but
Do you
it's an
think it saved
effective.
energy in the end?
Yeah, it did save energy.
Okay.
So the one thing about HVAC design engineers is they are so smart. Like they figure out 8 million different ways to solve something. And it just blows my mind sometimes. I was like, whoa, that would work. So it's my hat is off to anybody that does this for a living because it's just a very complicated thing. And when you get it right, it's just like I want to smoke a cigar and hang out with them because they're so smart.
Well, thank you for the compliment. I'll
Yeah,
light up a cigar with you
there you
anytime.
go. Yeah.
Um, I want to ask you, you have all this experience. How many projects, by the way, have you guys worked on and gotten rebates for?
I think we're up in the low 200s.
Nice.
In my home state, we did about 27. And then people started asking us to go to the next state over where they were going to do a grow. And now we just kind of grew organically like that. We don't do a lot of marketing. You're never going to see a YouTube video of my expounding on energy modeling, but it's
Except this
basically,
one.
yeah, yeah, yeah. Till now I'm going to be a star. But yeah, so about a little over 200 rebate wise. It's we're closing in on $50 million paid out to our customers.
Nice.
So that's always gratifying. And it's interesting to see how people change, like the way the lighting has gotten so much better and the designers have gotten so much better. And it turns out that like when they size a state, this is a paper that I presented to ASHRAE. When Missouri was sized for its licensed canopy, they had 60 facilities with 30,000 feet of canopy. Now, at the time, maybe it was how many pounds did that represent of finished product? in 2019. That probably is more than doubled by now. And so one of the things I would like to see, if there's ever anybody watching this that's on the state regulatory side, is put an escalation rate on the productivity. You're asking people to do something that the more they make, the more product they make, the more money they make. They're going to get more and more productivity out of a square foot of canopy going forward, and that's led to disaster, I think, in some states where they have no limit on production, and you got 1,000 people coming in making huge amounts of product that can't sell, or even in limited states like Illinois and Missouri. I think we're 6 years in, we're at like 70% of the licenses are being used,
Wow.
and we have a super high consumption rate. So it's like, where is this all coming from? Well, it's coming from really smart people doing it and getting more pounds per square foot than anyone ever thought was possible when they designed the canopy sizes and that sort of thing.
So when
So
you say an escalation rate, what does that mean exactly?
it'd be an interesting academic study to see what is the productivity per square foot. Maybe one of your other people that you have on here in 2025 compared to 2020. Like, how many
Mm,
grams per square foot per year does a square foot create now? And I bet it's
right.
extremely higher than it was back then, because
Especially with mature growers, right? And mature operators. Yeah.
yeah, well, now everyone's putting under canopy lighting, and they're doing more with the fertigation and the just it's just like, if you put people in a business where more means you make more money, they're going to figure it out.
Hmm.
So I didn't figure it out. It's just I'm seeing it. I'm standing on the sidelines watching that pile get
How do
high.
you model under canopy lighting? What is the baseline for that? No under canopy lighting?
Well, it's basically the total ppf on the canopy. So
Okay. Okay.
under
Well, it
canopy
doesn't matter
lighting,
if it's top lighting or under canopy
yeah.
lighting.
So
Okay.
when you add under canopy, you're adding ppf in an area where the plant can't use it or couldn't use it before. And so now you've got a biomass response of the plant, and you're going to get more pounds or more grams of dry flower out of that plant.
Right, but what's the baseline? I mean, do you is the baseline like a total watts per square foot for the room? Is it just a ppf and the ppf is based off of the total number of fixtures you have? So even though you might have increased your lighting density by 30% by having under canopy lighting, you can still demonstrate savings
Well, as long
because
as
you
you're
could
at,
have more efficient under canopy lighting.
I would say, as long as the under canopy lighting had a PE ratio that was equal to or greater than the
Hmm.
top lighting, it's more efficient. That's the way I would look at it. But it is
But
more,
it's usually both, right?
yeah, yeah, it's both.
So does that make it less efficient? Because it's going to consume more energy overall.
It is going to consume more energy overall. So
Okay,
under canopy
right.
increases the energy unless you
But
dim
is
the.
that, do you model that or do you model under canopy lighting relative compared to under canopy, less efficient under canopy lighting?
We haven't really done that.
Okay, you haven't done.
Yeah.
I'm just curious because I feel like, especially when it comes to lighting, and you kind of mention this at the very beginning, is that I feel like there's a lot of manipulation with energy savings when it comes to lighting. Like, like we're not really running the lights 24/7. We're not really going to run the lights during, in a greenhouse on sunny days. But I feel like in order to maximize rebates, a lot of times we see the manipulation of the lighting use in order to maximize the
Yeah, and
savings calculation.
I mean, honestly, that ticks me off when people try to trick the utility into paying more than they should and
Hmm.
say that this is saving stuff that it won't. It's like, it's just not going to.
Right.
I
Right.
mean,
Yeah, we
that,
were asked one time to to do an energy savings calculation, assuming that they were going to run the light 24/7 in this greenhouse. I don't even remember where it was. And we're just like, we can't do that. You're growing cannabis. We know it's going to be a 12/12 cycle, first off, right? Let's just start there. Not
Yeah.
even to mention, what we're trying to achieve during the summer versus the winter.
Oh, they wanted to
Um,
say they would run grow lights 24 hours a day in
yeah,
the
yeah.
greenhouse
Like just, I guess, taking advantage of the
because that
lack
gives you
of knowledge
more
of the
dollars back.
codes people. Yeah, I don't know.
Yeah, it's wrong. No, I agree with you.
Yeah.
I mean, the
Um,
way I look at rebates and all this stuff is the money is as great as it is. You don't need to put your thumb on the scale. You don't need to
mm,
exaggerate. Try to do your best. And if you don't, if you're not sure, be conservative, and then
right.
just go forward that way. And if you're doing it honestly, then you can go to sleep at night and not worry about it. But the
I
people
agree.
that want to like,
Manipulate the system, right?
yeah, or they're going to give you, well, I don't even want to get into all that, but we refuse to do that. Like, we don't want to sell anybody's light or do anything. It's like, we'll be an honest arbiter of energy consumption and savings and do the rebate part. And that's it, you know,
Right.
and then get your money and go forward from there. So,
Right. So for, over the course of these 200 projects, you guys have learned a lot. You've learned what questions to ask. You've learned about scheduling, about the different types of lighting and HVAC systems, et cetera. And then you've gotten feedback, at least from the utilities, to say that you are within plus or minus 2%, which in energy modeling or any model, we usually say if you're within plus or minus 20%, you're doing a great job. And so I'm just curious how you are able to validate your models and just use data that growers or utilities or manufacturers are they providing you data so that you can fine tune or tweak, or that Train or Energy Plus modelers can also fine tune and tweak to try to get to the most accurate empirical energy model possible?
yeah, so maybe this is where I give a little shout out to Willie Stover, who I met at the ASHRAE conference last summer in Indianapolis. He's the data logger guy, and he goes in and he goes, well, here's what it's doing. Then that's super helpful. Then
Yeah,
we go to our model and go, well, that's what our model is doing too. So either the
nice.
model is right because the data is right. I would love to see that loop closed to where there was like a post-mortem on most facilities so that you could see that the modeled energy wound up becoming, and that's an issue in energy efficiency on lead and everything else, where they put all these bells and whistles into a building, and then they get a guy that's hired off the street making $10 an hour to run it. And it's like, well, it's not going to, all the bells and whistles aren't going to do their thing. And so designing it is not the point. It's operating it, commissioning it, recommissioning it, finding sensors that go bad,
Right.
constantly doing stuff like that. So that's something if anybody's out there and they hear me and they've got data like that, I would love to jump back in and do some modeling on a similar building and say, is this what we're showing too? So
Yeah.
it's a iterative thing where you're learning from reality.
What kind of data would be helpful to you? Is it load profile data? Is it hourly, monthly, annual energy use?
Well, the easiest thing to get is probably well, it would be monthly energy use
Okay.
and demand being an important part of it. And then another thing would be interval data. So the utility meter is measuring the energy consumption every 2 or 3 minutes. And say if we had every 15-minute interval data, our models kick out every 15-minute data, and we can look at it in two columns. Here's your kilowatt hours of actual, and here's your kilowatt hours of model, and do some statistics on that and see if were there times of day where it was really out of whack and there's something wrong with the model compared to the empirical data, or is there kind of a correlation there that you would do that. It'd be nice to get a statistician that really understood correlation to sort of say, yeah, I think this energy modeling output is statistically significant compared to the empirical data. So there's enough of a scientist in me to see that that would be the crowning achievement of energy modeling. I did do that on a facility in Michigan, and my curves were right there. Like basically a flower room is night, day, lights out, and then you got a flat thing, and it runs kind of the same every month. So if you're looking for that pattern, that jump, and seeing where it did the how much of it was lighting, you can back that out. That's a simple thing like
Hmm.
watts of lighting that's on. And then you can go in and say, well, the rest of that must be the fans and the air conditioners and the dehumidifiers running, and trying to that's what the utility is measuring. And so that was really gratifying to see that when I did put it in the spreadsheet, and that's when you get down to the nether regions of Excel of 8,000 hours in, and it's hard to hold down the page down button to get to the where you're going. But you start to see that and then put it on a chart, and you can kind of tell whether you're doing it correctly or not.
Yeah. So for growers, operators out there, if any of you have an energy management system or is sub-metering your energy use or recording interval energy use, please reach out to us, to me or to Jeff Kelley. We would love to hear from you so that we can validate these models. And Jeff, you are really focused on cannabis, but I know that there are other professionals and researchers out there who are also looking at other crops. Could you just speak to that real quickly?
Yeah, yeah. So I've talked to scientists, lighting scientists. What is who Bruce
Bruce Bugby?
Bugby? Great. Forgotten more than I'll ever learn about lighting. It's just these people that are experts on things that I'm a novice at. I'm always wanting to learn more, and the academics have the time
Mm,
to really sit there and chew on something. We get one done. That customer is going to get $100,000 rebate, and then we're going to the next one. So
right,
we're
right.
we're an assembly line. But it would be nice if there was an academic that said, all right, here's one, and the customer is willing to cooperate, and let's track this over time and see how accurate we are.
Yeah.
That would be wonderful to see that go. But yeah, we've made small strides at other indoor ag type facilities. And another thing we've looked at is data centers, which are very energy intense.
Yeah.
Um, that is kind of where the money is in the rebate game, but it's also where there's a huge amount of energy in general. And there's people in those areas that know more about it than me. We talked briefly about ASHRAE. That there was not a huge amount of interest at ASHRAE when we went and presented on this. We
I
all
know.
the 4 or 5 people that are into it are all there, and we're the choir, and they're up there preaching, and we're saying amen. But just in general, it's like this is this thing at the end of the industrial park that's there, and I don't even know anything about it. And
Mm,
I like to see it get a higher profile with ASHRAE and that sort of thing, because it's a lot of energy. I know you had sent me something about the carbon footprint of of,
right.
of CEA. There's no doubt that there's a lot of energy that goes into it. I don't feel bad about that. If you can grow something inside and get $1,000 a pound for it, who cares?
Right.
Like,
Especially if we can save water doing it. My soapbox is that when it comes to agriculture, it's water we should be more focused on than energy. To me, energy is going to figure itself out. I mean, if we just had the will, we have what? All the energy we need from the sun in like 1 square meter or something of land. Like
Yeah.
it's something ridiculous, right? So we have the energy. It's the water that we don't have.
I'm a bona fide tree hugging hippie about being efficient. So I don't want to act like, I'm the enemy of the person who is an activist in that area. But on the other hand, well, the only way to solve that is have it not be worth $1,000 a pound.
Mm,
As long as it's
yeah,
$1,000 a pound, and that's just a made up number. So
right.
some
And that's
people are
what's
going to.
happening, right, Jeff? Is that they're, in some of these mature markets, California, Colorado, Washington, and a few others, is that the prices have gone down so much for cannabis that now growers are interested in efficiency, right? And how they can reduce their cost of production, not just increase their rate of production, and looking at the profitability equation from both sides of the line. And so I think, yeah, I agree with you. I think as prices go down, then there's going to be a lot more incentive for growers to think about efficiency.
Yeah, I was in southern Missouri, which is beautiful, but is not exactly a progressive area. This chicken factory had closed up, and all the chicken coops were just sitting there empty because they had no place to go with their chickens. So the guy was going to build tomato greenhouses out of the chicken coops. So he's going to take the roof off, put and start growing, and he was going to put some grow lighting in there for supplemental lighting in a chicken coop. It's like brilliant, do it. And then I said, well, how much can you get for a pound of tomatoes in the winter, like when the tomatoes taste terrible from the grocery
Right.
store? And he said, oh, we've gotten as high as $1.20 a pound.
Yeah,
A
that's
dollar
farming.
twenty a pound is not much money, and it's like,
Yeah.
how much are you going to spend to get $1.20 a pound? So
Exactly.
it's
Exactly. A lot more, there's a lot more incentive on the produce side of indoor farming than on the cannabis side for sure.
yeah, yeah.
Yeah. Yeah.
So, I was like, this is so great. I'm in the beginnings of this. And then I heard the number and I'm like, well, no wonder you need government incentives or free everything to, it's like when there's just really no market, and would
Right.
people pay $10 a pound for that? Probably not. If I was in the grocery store and it said locally grown delicious tomatoes, and I'm not going to pay $10 a pound. I'll get the other kind.
The
So
orange ones
yeah,
from
yeah,
Mexico. Yeah.
right.
Yeah, I know that Dr. Li Ping Wang at University of Wyoming, she's also working on energy modeling for lettuce crops and other vegetable crops and doing kind of similar work that you're doing, not necessarily for energy incentives because she's working through the university, but I think she's trying to develop a module, right? A plug-in to Energy Plus that can more accurately model the dynamics of say lettuce crops. And so, like you, she's looking for energy data to validate those models. But the thing with lettuce farms is that we have these vertical farms, we have single level. And there's a lot of variety in lettuces. We think there's a lot of variety in cannabis. There's, equally as much variety in lettuces, and just leafy greens in general. And so, any of you who are willing to share your energy data, your interval data, definitely Dr. Li Ping Wang at University of Wyoming would be interested in hearing from you. And, just kind of to wrap up, Jeff, we've talked a lot about energy modeling from a utility incentives perspective. But I was just wondering if you could just kind of rattle off or touch base on some of the other uses of an energy model and why growers would be interested in an energy model, or why we know that some codes and standards are interested in the work that you are doing with energy models. Kind of bring us home like full circle, like the big picture of energy modeling.
Yeah, I would like to see more of it being done because for policymakers, they live in a desert of data. I mean, there's a lot of
Mm,
utility data. There's data coming out the wazoo, but it doesn't sync to your lived experience. I would like to see more and more energy models done. I would like to see more requirement of an energy model. I'm going to pay $100 for an LED grow light. I would like to see. I'm going to pay 10 cents a kilowatt hour for an LED grow light savings that's proven in an energy model. Dig a little deeper, get it right, so that everybody's pulling the same direction, and you don't have these anomalies of so many dollars a pint or so many dollars a BT ton and stuff like that. Like
hmm
let's get down to the reality of it, and make our system and our utility based on actual data that our government scientists create. Energy Plus, that we've mentioned several times, is the result of thousands of brilliant people doing this work for the last, I don't know, how many years do you think it's been? 25, 30 years?
25, 30, yeah,
Yeah.
probably.
So it's like we do this and then we don't use it. It's like, well,
Mm,
use it, use energy modeling. And I would say to the growers that are out there, we would happily give them the energy model and say, put it on your computer and get a copy of the program and just keep running it. And then as you change things, we'll help you learn how to modify the energy model. So that now when it's like, well, this guy wants me to put in under canopy lighting, well, go into the lighting section and add it, hit the button, and that's how much your bill is going to be in the
right,
future. And then
right,
compare that to your projections for productivity.
right.
That's what Boeing is doing. That's what every huge company in the world is doing. It's not really that
Right. Those are your key
mysterious.
performance indicators, right? Is if you make one change, then how is that going to affect everything else, including your rate of growth, your overall yield, your quality. It's not necessarily about saving or using more energy and increasing or decreasing costs, but at the end of the day, it's how it also compares to what your revenue is going to be by making
Exactly.
that
You know,
change.
it's like you're a business person. Use it for business purposes. Don't use it just for like, our carbon footprint is lower or something like that, which is fantastic. But like, I'm looking at next year's budget. How much am I going to try to sell? How am I? How's the guy 3 blocks away doing this? And how can I be more productive than him and be
Be
more
more
efficient?
competitive.
Yeah.
Yeah.
So
Yeah, I mean, I think we mentioned, or I mentioned earlier too, I mean, one of the things that how we use energy models is for alternatives analyses to identify best management practices and optimization, and just trying to find the most efficient option or system or strategy that is going to either produce the same yield or produce a higher yield. At minimum, do no harm, right?
yeah,
I don't think that growers take enough advantage of that, or developers in the early planning stages. Is if Jeff, for example, has an energy model that he can use to get you incentives, that's awesome because that's going to help reduce your first cost, your capex. But he can also use that energy model, or he can give it to you or give it to us, and you can run it to see how it's going to impact your operating, your ongoing costs. So it's one thing to reduce your costs today, a fixed cost savings today, but also how is that going to translate into future savings? And so especially Jeff, if your model is within plus or minus 2% accuracy, then that's not just using like a code-based energy model for baseline comparison, right? Like to say, oh, this is how much savings, in theory, we can make. You're actually you have such an accurate model that you can help growers actually predict how much energy they're going to use at their operation, not necessarily in comparison to someone else's or some other design. And so that is really impactful for developers and investors who are thinking of building a new cannabis facility. So I see there's a lot of benefits. I know that, there's like Resource Integration Institute, and they've been trying to collect data on one hand, to even identify what is considered an efficient operation versus I don't know if it's an inefficient operation, but just right, like, and to try to figure out like what are the strategies and systems that make a facility use less energy than say another one. But there's value in that. But I think for you personally, the growers, the developers, the investors, just knowing what your costs are going to be, what your investment is going to be, having an energy model to help support those decisions, I think is really valuable.
and have it be in your location. So,
Absolutely.
you
Yeah.
know, and one good thing about the energy modeling program that we have, you could do it in Mexico, you could do it in Europe, you can situate, and you could do it in SI units. So,
For our
I
friends
have
in
a,
Canada and other
yeah,
everywhere
for all
else in the
you
world.
Jules people out there, you can do that, and then
Yeah.
my brain will melt, but maybe I'm melting your brain by using tons and all the silly, you know, imperial, what do you call it? The imperial system or whatever.
Yeah, the imperial system.
Right. So
Um,
yeah, it's a good thing to do, and really, I what I want to say is I want them to be successful, and I want them to grow and make money, and I just want to be one of the people that helps them push that bike out of the pit and back out on the race course, and they can go as fast as possible. So that it's really about helping them,
yeah.
and trying to help myself a little bit at the same time, obviously, but it isn't some, I don't care what happens to you after this. I want to see you. And like right now, I'm in the Missouri Cannabis Association. I'm going to go down to this trade association, and I'll have 60 guys that I've worked with, and I was like, how's it going? And they're like, it's going great. So, or it's not going great, and I learned something. So we'll
Right,
see.
right. Um, well, Jeff, to wrap things up, I have one final question for you, which is what is energy?
Yeah, I looked that up because in all honesty, I got a little bird told me that was going to come, and really, what I think the thing is just my culture that I come from. To me, energy is a bill. It's something you have to pay for, and the less of it that you buy is saves you money. Now, energy is has an abstract, it's the change in the heat flow across, or the motive force to our power versus energy. Power is one thing and energy is another. But I think to most people, when you say energy, they go, my electric bill, my gas bill, my gasoline bill on my car. That's what they think of as energy, is a bill. And I think
Interesting.
that's what I'm going to stick with. It's like it's a cost. You got to pay for it, and it has to be done for you. If you can build a power plant in your backyard, good luck.
Right.
So, but
That
that's
is very profound. That's a
yeah,
very profound
yeah.
response.
I don't think I'll win any poet laureate of energy efficiency awards for that, but
But it's true.
anyway.
I mean, it is a part of our cost of living is the use of energy and the conversion of energy. Yeah, there is no free energy.
And it's like taxes. You're going to be paying for it. the day that you start earning money until the day you are gone.
Right.
It's a constant.
Interesting. So the only three absolutes are death, taxes, and energy,
Electric bills.
and the electric bills.
You can even get rid of gas, but you'll still have electric.
You
So
will,
yeah,
exactly.
it's gonna never go away.
Oh, thank you. Thank you for that final thought. I like it.
All righty.
Well, I have to ask, so we're almost done. So I have five unofficial questions. They're rapid fire questions,
Okay.
and they're just meant yes, no, one sentence, one word. You don't have to explain or expand on any of these
Shoot, I'm
questions if you don't
ready.
want. All right. First question, what energizes you?
What energizes me is helping people.
I like
Feeling
it.
like I help someone move forward. And
Okay.
if I know that that's going to happen, I'm excited to go there and do it.
How much energy is too much energy?
Too much energy is more than you need to do the job. So what's the job? And just uses exactly enough energy as you need to get the job done. Don't
That's
use more.
perfect answer. What is the most underrated energy efficiency measure in CEA?
I think the energy management system,
Okay.
it,
Yeah, controls,
turn it down,
sensors.
turn
Yeah.
it up, adjust it. I was listening to a speech on economics, and they said the Federal Reserve either tightens or loosens the screw. It's like that's their only. They have been given one data thing that they can move. Well, energy management system is the one thing that you really need, because if you can't change things, you're in the blind. You're
Yeah.
in the dark.
If you could be one type of energy, what would it be?
That's a good one. It's funny because for almost 30 years I was a natural gas guy, and then the last 20 years I've been, well, not that long, but ever since I've been electric guy. But I think I like electric.
Okay. All
It's
right. Your
magic.
electricity. Your
It's
elect.
electricity is magic. It does, like, I can pick up my phone and learn all about the world. And without
That's
electricity,
true.
I can't do that. So I think I like electricity.
Okay. All right. Awesome. All right. So you're from Missouri. So St. Louis, right?
Yeah, yeah.
Okay. All right. So this is a hometown question. Okay. If you could only choose one, the Chiefs, the Royals, or ribs?
They ripped California stole our football team, and I boycotted for 5 years. But man, having the Chiefs, they're pretty good. They're pretty good.
All right.
But if you're going to go to Kansas City, get
Right.
ribs. They're awesome.
I did have ribs a year ago. I was there and they were delicious. Yeah, we couldn't
Yeah,
eat them
yeah.
all and we took them with us everywhere to finish.
Right. Yeah. Make sure you get the toothpick on the way out, because
Absolutely,
you'll be digging
absolutely.
away at that last bite that you squished between your molars.
It's always the last bite that does it.
Yeah.
Yeah. Well, Jeff, thank you so much for talking about energy modeling with me. It is such a valuable tool that I would really like all indoor growers to be using more and taking advantage of. So thank you for your good work. Thank you for your accurate work. And yeah, I hope to see you more
Yeah,
in the
well,
world of
thank
CEA.
you. I was one of the people in the back row at one of the many seminars that you spoke at, and we always would point people to the Dr. Greenhouse website and podcast. It's like, if you want to understand this, here's somebody who's an honest broker of this information. So I'm honored to be on here with you, Nadia, and I really appreciate it. Thank you so much.
Thanks so much. All right. Thanks, Jeff.
Okay, take care. All right, bye-bye.